Welcome to the Ham Radio Nomad study session. So I took the practice test last week and I failed. And let's see if I can bring up let's see. Let's see if I can bring up the score from last time. So, and okay. There we go. So this is the score that I got last time. 32 out of 55. So let's see how I do this time and see if I get better or not. So it was a very packed time. I think it took about an hour and 10 minutes, hour and or so. So let's see how. So I will be speeding through this probably faster than I would on when I actually do take the test. But let's see how things go. And welcome to No Code Tech in the chat. Thank you for being here. What are the major spectral impurity components of direct digital synthesizers? A, spurious signals at discrete frequencies. B, broadband noise. C, digital conversion noise. D, I have no idea how to pronounce that, something limit noise. I'm going to go with B, broadband noise. What is used to control the attenuation of RF signals by a pin diode? A, capacitor, the capacitance of an RF coupling capacitor. B, subharmonic pump signals. C, forward DC bias current. D, reverse voltage larger than the RF signal. Oh, I am not starting off with a good start since I don't know either of these. So I'm going to go with C. Which of the following types of signals can be relayed through a linear transponder? A, PSK and packet. B, FM and CW. C, SSB and SSTV. D, all of these choices are correct. Um, Linear transponders are, I believe, are what is on linear satellites, and you can pretty much send everything through them. So I'm going to go with D. What usually occurs if a Yagi antenna is designed solely for maximum forward gain? A, the SWR is reduced. B, frequency response is widened over the whole frequency band. C, front to back ratio increase. D, front to back ratio decreases. Um, it is one of these, and it's a question of, I believe it is the front gets more than the back, so I'm going to go with the C, front to back ratio increases. Which of the following best describes a volunteer examiner accreditation process? A, the amateur operator applying must pass a VE examination administered by the FCC Enforcement Bureau. B, the procedure by which VEC confirms that a VE applicant meets FCC requirements to serve as an examiner. C, each general, advanced, and amateur extra class operator is automatically accredited as a VE when license is granted. D, prospective VEs obtain accreditation from the FCC. Well, D and A aren't correct because it's not directly from the FCC. C isn't correct because it isn't automatic. So it must be B. Which point in figure E5-1 best represents the impedance of a series circuit consisting of a 300 ohm resistor and an 18 microhenry inductor at 3.505 megahertz? A.3 Y400 X300, B.8 Y50 X300, C.1 Y negative 400 X 300, 0.7 negative 400Y negative 300X. C, basically I've seen it like this question like 3 times and I've memorized it because that's the only way I'd be able to know that one is by the fact that I memorized it. What is the most common method of reducing key clicks? A, high pass filters at the transmitter output. B, low pass filters at the transmitter's output. C, reducing keying waveform rise and fall times. D, increasing keying waveform rise and fall times. And I had this question last week, and I got it wrong. And I don't remember what the right answer was. I'm going to go with reducing keying waveforms rise and fall times. What does a 304A solar parameter measure? A, the solar emissions at 304 gigahertz correlated to X-ray flare levels. B, the ratio of X-ray flux to radio flux correlated to sunspot number. C, solar wind velocity at 304 degrees from solar equator correlating to solar activity. UV emissions at 304 angstroms correlating to solar flux index. I'm going to guess that it's D. What is color information set? How is the color information sent in an analog SSTV? A color information set. Oh, I can't speak today. Color information is sent in on a 2.8 kilohertz subcarrier. B color is amplitude modulated on the frequency modulated intensity signal. C color is sent in the color burst at the end of each line. D color lines are sent sequentially. Um, I'm going to guess B. Um, Unfortunately, this is one question I have not. I don't remember seeing at all. So I'm going to guess that it's B. Which of these digital modes has the narrowest bandwidth? A. PSK31, B. 300 baud packet, C. MFSK16, D. 170 hertz shift 75 baud RIDI. I'm going to guess RIDI. What core material property determines the inductance of an inductor? A. Permeability, B. Resistance, C. Reactivity, D. Thermal impedance. Permeability. It is how permeable, how the magnetic energy can go through the material. What is antenna efficiency? A. Radiation resistance divided by transmission resistance. B. Radiation resistance divided by total resistance. C. Effective radiated power divided by transmitter output. D. Total resistance divided by radiation resistance. And I'm going to go with radiation resistance divided by total resistance. Why is choroidal Hop propagation desirable? The MUF for choroidal Hop propagation is much lower than normal skip propagation. B. The signal experiences less loss compared to multi-hop using Earth as a reflector. C. Atmospheric noise is lower in the direction of the choroidal Hop propagation. D. Signals travel faster along ionospheric chords. I believe it's B. The signal experiences less loss compared to multi-hop using the Earth. What is the half power bandwidth of a resonating circuit that has a resonant frequency of 7.1 megahertz and a Q of 150? Oh, where is Don or the Smoking Ape? Both of them have been studying and looking at the Q of antennas and circuits. And I am just gonna guess. Yeah, I'm gonna guess that one. B, 23.67. What advantage does a series pi L network have over a series L pi network for impedance matching between the final amplifier of a vacuum tube transmitter and an antenna? A, does not require a capacitor. B, higher efficiency. C, greater transformation range. D, greater harmonic suppression. I'm going to go with greater harmonic suppression. What is the typical output impedance of an op amp? A, very high. B, 100 ohms. C, 1000 ohms. D, very low. I'm going to go with very low. Next question. Which of the following has the largest effect on an SDR's receiver's dynamic range? A, analog to digital converter sample width in bits. B, CPU register width in bits. C, anti-aliasing input filter bandwidth. D, RAM speed used for data storage. And I am going to go with A, analog to digital converter sample width in bits. What parameter describes the interaction at the load end of a mismatch transmission line? A, dielectric constant. B, velocity factor. C, reflection coefficient. D, characteristics impedance. I'm going to go with it's a mismatch and it's a load end, which is the side with the antenna. I'm going to go with the reflection coefficient because it's where the energy would be reflected back if it doesn't when it doesn't match. What is the purpose of a prescaler function on a frequency counter? A, it prevents oscillation in a low frequency counter circuit. B, it multiplies a higher frequency signal so a low frequency counter can display operating frequency. It divides a higher frequency signal so a lower frequency counter can display the input frequency. D, it amplifies low signals for more accurate counting. I'm going to go with B. And just for reference, until we see the final outcome, I do not know if these answers are right or not. So don't be, go through these questions and answer what you think they are. Don't judge your answers by what mine are because mine very, very well could be wrong. What undesirable effect can occur when using an IF noise blanker? A, nearby signals may appear to be excessively wide even if they meet emission standards. B, FM signals can no longer be demodulated. C, received audio in the speech range might have an echo effect. D, audio frequency bandwidth of the received signal may be compressed. I do not use a noise blanker very much, but I'm going to go with C. Audio may have an echo effect. What is receiving directivity factor? A, forward gain compared to average gain over the entire hemisphere. B, relative directivity compared to isotropic. C, relative directivity compared to a dipole. D, forward gain compared to the gain in the reverse direction. I'm going to go, a lot of stuff is, I'm going to go with that compared to a dipole. What is the term for the reduction in receiver sensitivity caused by a strong signal near the receive frequency? A, squelch gain rollback. B, quieting. C, desensitization. D, cross modulation interference. Desensitization is reduction in sensitivity, so I'm going to go with that one. In figure E6-3, what is the schematic symbol for the NOT operator? A2, B4, C6, D5. Okay, so 2, I believe is what it is, but let's look at the other one. Oh. So 1 is and, 2 is not and, 3 is or, 4 is not or, 5 is not, and 6 is, I don't know what 6 is, but not is a single input, single output operation, and that is the only one that is a single input, single output of the options, so it must be 5. How does DC input impedance at the gate of a field effect transmitter compared to the DC input impedance of a bipolar transistor? A FET has a higher input impedance. A FET is the field effect transistor. B, both have low impedance. C, both have high impedance. D, a FET has lower input impedance. Oh, I'm going to go with D. Probably wrong, but yeah, I need to move. So I'm making better time than last time. I'm at the halfway mark, and I'm 23 minutes into the. So I'm not even halfway in my time. So that is what I want, because I do want to be able to go through the results and go through and look at what answers are correct. So I do want to. I hopefully will come in. I want to come in at about 7, about 10 minutes to the hour, so we can review the answers. What do the subscripts of S parameters represent? A, relative quality of the data. B, relative time between measurements. C, the ports at which measurements are made. D, frequency order of the measurements. I'm not exactly sure. I'm going to go with D. No. How does the total amount of radiation emitted by a directional gain antenna compare to the total amount of radiation emitted from a theoretical isotropic antenna, assuming each is driven by the same amount of power. A, the total amount of radiation from a directional antenna is increased by the gain of the antenna. B, total amount of radiation from the directional antenna is stronger by the front to back ratio. C, they are the same. D, the radiation from an isotropic antenna is 2.15 dB stronger than that from that of a directional antenna. They are looking at the total power, so it is the same. The advantage of a directional antenna is that it takes the power that would be from the back side and focuses it on to the forward side, or on the gain of a omnidirectional antenna, like a 5/8 wave antenna, is taken from, it is taken by squishing the field so that more of the power goes at the what people think is a preferred takeoff angle. So not as much is going directly into the sky. Under what circumstances may a dealer sell an external RF power amplifier capable of operation below 144 megahertz if it has not been granted FCC certification? A, the equipment dealer assembled it from a kit. B, it was imported from a manufacturer in another country and was certified by that country's government. C, it was purchased in used condition from an amateur operator and is sold to another amateur operator for use in that operating station. D, it was imported from a manufacturer in a country that does not require certification of RF power amplifiers. C, it is used equipment. That is the only way for things to get grandfathered in. Within what distance must an amateur station protect an FCC monitoring facility from harmful interference? A, 1 mile. B, 10 miles. C, 3 miles. D, 30 miles. I believe it's 1 mile. Which of the following is a good technique for making meteor scatter contacts? A, use of special digital modes. B, short transmissions with rapid repeated call signs and signal reports. C, all of these are correct. D, 15-second time transmission sequence with stations alternating based on location. I'm going to go with all of these are correct, since I believe B and D describe the same thing, and I think it's they're describing special digital modes. So I'm going to go with that they're all describing the same thing. What is the relationship between AC current through a capacitor and the voltage across the capacitor? A, voltage and current are in phase. B, voltage leads current by 90 degrees. C, voltage and current are 180 degrees out of phase. D, current leads voltage by 90 degrees. And I don't remember this one. I'm going to say they're in phase. What type of amplified circuit is shown in figure E7-1? A, common base B, emitter follower, C, common emitter, D, common collector. I don't know. I'm just going to guess C. What circuit is added to an FM transmitter to boost to higher audio frequencies? A heterodyne suppressor, B, a heterodyne enhancer, C, pre-emphasis network, D, a de-emphasis network. Heterodynes are I hear that in relation to FM or not FM HF's HF radios, so I'm not going to go with that. De-emphasis talks about attenuating and lowering, so I'm going to go with pre-emphasis. Which of the following device packages is through-hole type? A, DIP, B, PLCC, C, ball grid array, D, SOT. Um, I do not know. I'm just going to go with DIP because I don't know. I don't really know what the other ones are. PLCC, I vaguely remember. It sounds familiar, but I don't know what it is. And the other two, I'm completely don't have any idea what those are. Which of the following is required in the identification transmission of balloon-borne trimetrical station? I'm just going to, I see the right answer as A, call sign, and going to move on. Call sign is what's needed for identification. What is the cause of auroral activity? A, the interaction of the F2 layer between solar wind and the Banyan belt. B, meteor showers concentrated in extremely north and south latitudes. C, interaction in the E layer of charged particles from the sun with the Earth's magnetic field. D, extremely low pressure area in polar regions. B and D are automatically out. And the question is it A or C? I'm going to go with C, but both of them are very close. Yeah. Which of the following is a measurement of the quality of an analog to digital converter? A, peak envelope power, B, power factor, C, reciprocal mixing, D, harmonic distortion. Peak envelope power is talking about something else. Power factor is also talking about something else. I'm going to go with total harmonic distortion. What impedance does a half-wave transmission line represent? What impedance does a half-wave length transmission line present to a generator when the line is shorted at the far end? A, very low impedance. B, same as output impedance of the generator. C, the same as the characteristics impedance of the line. D, very high impedance. Very so I'm going to go with very high impedance, and the reason why is a transmission line that is shorted on the far end is basically going to be a infed half-wave antenna. And an infed half-wave antenna has a 49-to-1 balun on it, which is taking a very high impedance and a 49 impedance down to um, down to 50. So that's where I'm, and so that ratio is very high. So I'm going to go with D. What describes orthogonal frequency division multiplexing? Ouch. That's a lot of big words. A bandwidth compression technique using Fourier transforms. B, digital mode for narrow band slow speed transmission. C, a frequency modulation technique that uses non-harmonic related frequencies. D, a digital modulation technique using subcarriers at frequencies chosen to avoid intersymbol interference. I am going to go with the, um, yeah. Which of the following contacts may be confirmed through the US QSL Bureau system? A, contacts between a US station and non-US stations. B, special event contacts between US stations or between stations in the US. C, repeater contacts between US club members. D, contacts using technical call signs. Um, I'm going to go with A. What logical operation does an OR gate perform? It produces a logical 0 if the output of all inputs are 1. Nope. It produces a logical 0 if the output when if at it produces a logical 0 at its output when all inputs are logic 1. Nope. It produces a logic 1 at the output if all inputs are logically 0. Nope. It produces a logic 1 at its output if any or all inputs are logic 1. And that is correct. What is the approximate open circuit voltage produced by a fully illuminated silicon photovoltaic cell? That is A, 0.1 volt, B, 12 volts, C, 0.5 volts, D, 1.5 volts. I'm going to go with C, 0.5 volts. I believe each of my solar panels is about 72 cells, and it's about a 32 volt panel. What is but just for reference, that is what I'm remembering. I do not know that. I'm not 100% sure of that. So we will find out what the correct answer is in probably about 15 minutes, maybe about 10 minutes. I'm almost done. I have 9 questions left. What is the primary function of an external earth connection or ground rod? A, reduce RFI to telephone and home entertainments systems. B, reduce RFI or RF current flow between pieces of equipment. C, lightning protection. D, reduce receive noise. And we want external earth connection or grounding rod is um, primarily for like lightning protection. Which of the following is required in order to operate in accordance to SEP rules in a foreign countries where permitted? A, you must identify in the official language of that country in which you are operating. B, you must bring a copy of FCC Public Notice DA 16-1048. C, you must append /SEP to your call sign. D, the U.S. Embassy must approve your operation. I believe I've seen this one, and it is B. You have to provide a copy of the public notice, and that is my guess of why that is because most people will, most officials like the police of where you're operating will not know the rules, so you are bringing them a copy of the rules that tell them that you are allowed to under SEP rules. What is the bandwidth of 400, 4800 hertz frequency shift, 9600 baud ASCII FM transmission? A, 9.6 kilohertz, B, 15.36 kilohertz, C, 4.8 kilohertz, D, 5.67 kilohertz. I'm going to guess that it's 9.6 kilohertz because I think, and we'll find out shortly, that the frequency shift doesn't have any, it just shifts it. It doesn't do anything with the bandwidth. What kind of digital signal processing audio filter is used to remove unwanted noise from a received SSB signal? A, adaptive filter, B, crystallattice filter, C, Hilbright transform filter, D, a phase inverting filter. And I'm going to go with a adaptive filter. What is the equation for calculating the power dissipated by a series linear voltage regulator? A, input voltage divided by output voltage. B, output voltage multiplied by output current. C, input voltage multiplied by input current. D, voltage difference from the input and output multiplied by the output. Okay, so it's not, I'm pretty sure it's not B or C. I'm going to go with D. Because yeah, the difference is the power that's dissipated, and then it's in, I believe it's in reference to the output current. No, I don't know. I'm actually going to probably come back to that one. I'm not exactly sure. What is the process of normalization in regards to a Smith chart? A, reassigning reactance values with regard to resistance axis. B, reassigning resistance values with regard to reactance axis. C, reassigning impedance values with regard to the prime center. D, reassigning the prime center in regard to the reactance axis. I'm going to go with D. What is the radiation pattern of two quarter wavelength vertical antenna spaced halfway apart, fed 180 degrees out of phase, and that is choroidal. And just for reference, this is the website I'm pasting is the one that deals with um, how two antennas um, behave. And there is a series of 3 or 4 questions um, that deal with it in different things of whether they're in phase, out of phase, 90 degrees, whether they're half wavelength apart, quarter wavelength apart. And I believe this one is choroidal. And welcome, Joseph. Almost, you just got here in time for it. I'm almost done with the exam. You'll see what if I passed or not, and we'll go through the questions that I got wrong. How many watts are consumed in a circuit having a power factor of 0.2 if the input is 100 volts and the amps is 4 amps? And so if the 100 amps, okay, so 100 volts times 4 amps is 400 watts, and the power factor is 0.2, so that's going to be, now the question is which way are we going with that? Are we dividing it or timesing it? Let's look at my calculator just to see. So 400 watts times 0.2 is 80. 400 watts divided by 0.2 is 2000. So I'm going to go with 80. I think it's less. So, and okay, I'm going to, yes, I see you commenting there, Joseph, and I will read it in just a moment. But I want to finish this up a moment. Where must the carrier frequency of a CW signal be set to comply with FCC rules for 60-meter operation? C, highest frequency, B, lowest, C, any frequency where it's in the signal sideband within the channel, D, center. For 60 meters, everything is centered. So, okay. So this is the comment that Joseph made. A half square has a radiation pattern that is a figure 8, and it's 2 quarter waves of a half part. Okay. Yeah, that's if the link that I sent goes into details and I'm not yeah, I could look it up, but yeah, I just guessed that, and yeah, a lot of times and these nope. There's one that I wanted to go back to. And now I can't find it. I thought it was like this one. What is the equation? Oh, I'm just going to leave it. So, I am done with the test. And now it is time for me to grade it. So my score from before was this: 32 out of 50. My score today is 33 out of 50. One more correct than last time, but still 2 questions shy of passing. So let's go over the questions. So what is a so right out of the gate, got the first one wrong. And the major spectral impurities is spurious signals on discrete frequencies. Okay. So the next one, okay, I had it backwards. The for the ratio decreases when you do forward gain. Oh, I got that one wrong. Okay, they must have similar uh, similar questions that go to different points then. So 300 ohm, so 18 microhenry at 3.5 is a positive 400. Okay, so that's okay. So it is an issue of whether it is a question of whether it's an inductor or a capacitor. If it is an inductor, like this one is, it is 3. If it is a capacitor, it is 1. So that's the thing to watch out for when you get to this question. Is it a capacitor or is it an inductor? And this was the one that I had last time and I didn't remember it. Okay. And I did the opposite one. So it's increasing the keying waveform increases. So it is the opposite. So to reduce the keying clicks, you have to increase the keying. Okay. And so this one, color information is, the color lines are sent sequentially. And PSK 31 has the narrowest bandwidth. So bandwidth equals frequency over Q. So divide, okay. So divide the bandwidth by the Q and you get the, and that's the answer. Okay. And then I get the opposite one again. It divides the the prescaler divides the frequency so you can display the input. And a noise blanker causes things to appear excessively wide. And it's forward gain. RDF is forward gain compared to average. In fact, I got the wrong one. I'm getting the opposite one on all of these. FET has higher input impedance. And S deals with what ports? So yeah, and didn't know this one either. So for a capacitor, the current leads a voltage by 90 degrees. It's another one. Is there helpful way to remember the relationship of current and voltage in inductors and capacitors is I don't capacitors current leads voltage, inductors inductors voltage leads current. Yeah, I knew no code tech. I was good at filtering out the nonsense answers, but then it was like the two that were relevant. I did a bad time at guessing which one was right. Ooh, I was thinking this one was right. Okay. What does the impedance of a half wave length transmission line present to the generator when it is shorted? At a half wavelength, the end of the transmission line matches the amplitude of the input to the transmission line when the standing wave exists. As such, shortening will take the energy out of the standing wave and it'll be seen as a short at the generator, which is low impedance. Contrast this to a quarter wave long transmission line where the peak amplitude of a standing wave at the generator corresponds to a node at the end. If you don't terminate, the reflective wave will be 180 degrees out of phase. Um, yeah, yep, yeah, that's no code tech. Yeah, that's basically you're doing a full loop at that point. So yeah, if you short a half wavelength transmission line, you're going there and back, which is going to basically be a full loop. And I was right about each cell is half a volt. And I was wrong about this one. Frequency shift is, so bandwidth, so keying is 1.2. So it's 1.2 times the shift plus the bandwidth. Um, they have some thing of, okay, they're both 4 digits and the answer has 4 digits. My way of thinking is just remember both things have both of the 448 and the 96 interact. So it's going to be more than each individual one. So it's going to be more than 96. It's going to be more than 48. And the only one that's more than both of them is the 15.36. Adaptive filter and normalization. Okay. And again, I knocked out the two that didn't make sense. And I knew it was something to do with the prime center, but it's resigning the impedance, not resigning the prime center. And this one was the one that Joseph said I was wrong on. So yes, it's figure eight oriented along the axis of the array. And that is all the questions for the test, and I am 2 minutes over. So thank you all for joining, and I'm getting better. So, and I sort of said this to myself that if my score improves, I'll do another practice test next week. If my score decreased, then I'd go back to just doing the standard questions. So 73, thank you for joining me, and I will be going through another practice test next week. So thank you for watching, and hit the thumbs up if you haven't, and have a good weekend. And I will see you hopefully on the FT8 off practice, either that or next week. Thank you and take care.